Finally, if I find out inside the bracket, 4 is the LCM here. So 4 is to 2 is A4 minus A4, that means A4 upon 4. Answer will be, that means right here. So final answer of this will be K into B square upon A square, as it is. From inside you will get A4 upon 4. After taking 4 LCM, will be twice A4 minus A4 upon 4. That means A4 upon 4. A4 upon 4. 1 A square cancelled out. It is nothing but K upon K into A square B square upon 4. Yeah, this is the answer here. The answer this is K A square B square upon 4. Finally, it may, this is the unit of this. Mass is equal to this much unit. It may be kg or it may be kilograms, grams, whatever it may be. If it is grams or kilograms, unit may be there. But we have not write unit here. Only this is the answer. K A square B square upon 4. With K A square here and B square. So this whole power will be only A square here. So now this is A square. A square cancelled out. A square B square. Okay, only there. So this is answer question number first we have done. Now let me talk about question number second. What is question number second say? Let me check it. Okay. Okay, now question is second. Question second says find the mass of a circular plate of diameter A here. The density of which at any point is K times its distance from a fixed point on the circumference. At a fixed point from the circumference. Now let me take a circular plate here. Question number second. In this case, we are given a circular plate. Okay, with diameter A, let me take a circular plate. Like this. Okay, and diameter A to this point is A0A. Diameter, total diameter is A here. From this point to this point, total distance is A. Now if I take, okay, find the mass of a circular plate of diameter A, density of which at any point is K times its distance from a fixed point. If I take, let me take the polar coordinates of this, let me take. Polar coordinates, if I have to denote, the polar coordinates are, as I discussed in case of change of variables. If I take polar coordinates in terms of polar coordinates, rho r theta, okay, at r theta, density is at r theta, rho r theta into, in place of d.x.d.y, we will write r dr d theta. That is already known to us. Okay, or in case of solid figures, we have to write down that change into polar coordinates. Polar coordinates r theta phi. We will discuss that in some of the questions here. If polar coordinates are given, okay, if we have to change the given variable into a polar coordinates, then we will write that in there. Sorry. Okay, so the density of which at any point is K times of this. Okay. Density is K times its distance from a fixed point on the circumference. The circumference is this. Okay. Now this is A here. So for the density of this point, I'll just note down the rho is equal to the distance of this point. Let me take this distance is A. This is A here. Up to this diameter is A from this point to this point. Okay, so this is diameter A. So at point rho A equal to cos theta. If I have taken any point here, so rho equal to A sin cos theta or R equal to this. If okay, let me first take this x O y dash. This is x. What is given to us? Let me take on that also. Find the mass of circular plates. Circular given a circular plate. We are given a circular plate circular plate here. One thing, then density is also given. Density is given as k times its distance from the fixed point on the circumference. Rho density equal to, let me take, it is k into r. R is the density if it is in case of circumference distance from this point is this. Suppose this is r here. This is r per delta r. This length is okay, and this is theta here. This is d theta here. This is r. Okay, from this point to this point is r per d r. At this point, if I have to find out, or at this point, this is a sine a cos theta. Up to this length is a cos theta, or if I take like this point, I want this, that it will be, this length will be r equal to a cos theta. That is what you call r equal to a cos theta. This is r equal to a cos theta. So r is equal to here a cos theta. This is r. This you call this a cos theta. Or radius is a cos theta. Let me take r equal to a cos theta here. This length you will take r, and theta is from minus pi by 2 to plus pi by 2. Okay, so this theta is equal to minus pi by 2 to plus pi by 2 from this circular plate. So inside this is minus pi by 2, and here it is equal to pi by 2. Theta is pi by 2. R equal to 0 to a cos theta. R equal to 0 to R equal to a cos theta. This is a here, and this length will be a cos theta, because this is hypotenuse. This is right angle, suppose. Okay, this length r will be equal to a cos theta. This is what we call limits of r here. R equal to 0 to a cos theta. And what is theta? Theta equal to minus pi by 2 plus pi by 2. Okay, so this is what we call limits of the two values. So we have to convert this into, let me take polar coordinates theta and r. So this is then the okay, we have to find out now what is the mass of this. So find the mass of the circular plate of diameter a. Okay, diameter is given a, and density of which at any point is k times its distance from a fixed point on the circumference. Fixed point on the circumference. Suppose this is the pointed circumference. So what is rho here? Rho is, let me take r into, because this distance is from this point. So r equal to a into, okay, k into r. This is k into r here. K into r. This is density. Okay, length of this point is from a fixed point r, suppose. So rho equal to k into r, where r is equal to a cos theta. Okay, so this is what we call given to us. So rho density is given, k into r times, okay, k into r. Alright, so then what is the total area therefore? So I mean total area, then mass. Mass we have to find out, solution we have to find out. So first elementary mass. So elementary mass of an element, elementary mass of the circle, let me take elementary mass of the circle or circular plate. I'm sorry, this is circular plate here. Circular plate is equal to rho into, first is d.x.d.y, let me take d.x.d.y, but this is rho r theta, rho at r theta into r dr d theta or d theta dr. Let me take here r d theta dr. This is r d theta dr, because we have converted this into polar coordinates. So dx d theta equal to r, because r is obtained after Jacobian. We discussed about this Jacobian in case of your change of variables in the previous lecture. So r comes out to be when we convert the Cartesian coordinates into polar coordinates. This is converted as Jacobian d theta dr or dr d theta. So this Jacobian comes out to be r, which we just converting them into polar coordinates. X equal to r cos theta, y equal to r sin theta. Then we find out this r here, so that is the point. So this is elementary mass. This is small m, let me take elementary mass of an element. Both an element we have taken here, this is an element here. Because this elementary mass is r d theta, dr into rho r d theta dr. This is elementary mass here, and rho at r theta point. Therefore, total mass of the plate, mass of the circular plate, is equal to, or mass equal to, double integral. First, limits theta minus pi by 2 to plus pi by 2. This theta minus pi by 2 to plus pi by 2. Whole plate is circular plate. Okay, then theta is theta 0 to theta we have taken minus pi r now. R equal to 0 to a cos theta. So r equal to 0 to a cos theta. Now what is the value? Rho here is k into r, or let me take k times r. K into r, which is rho here. First let me write rho here. This is rho into r d theta. This is value of dx dy, which is equal to minus pi by 2 to plus pi by 2, 0 to a cos theta. Alright. Now rho is k into r, but r into dr d theta or d theta dr is already given to us. R d theta dr is in place of a, but rho is k into r. Because at circumference, the length of any point on the circumference from a fixed point is, let me take r. Okay, so that k into r is given to us the rho value of rho density. Finally, what we get is minus pi by 2 plus pi by 2, minus a to plus a if it is, and we write here by property twice 0 to pi by 3. Try to understand. This is one of the property of definite integrals, that if it is minus a to plus a limits, and we write twice 0 to pi by 2, 0 to a. In this case, in place of a we have pi by 2. Okay. And second limit 0 to a cos theta. K into r square. K is constant, that we take outside. Twice k we have taken outside. Okay, and this is r square into dr. First I have to integrate it with respect to r. Let me write this in the curly bracket and leave theta outside. Finally we will integrate with respect to theta. But before that, let me integrate this with respect to r. Therefore, total mass m is equal to twice k limits 0 to pi by 2. Integration of r square is r cube upon 3 limits 0 to a cos theta into a theta. What is here? Twice a. Okay, limits 0 to pi by 2. In place of r, we have to substitute a cos theta. At 0 it will be 0, so it is 2 upon 3 that we take outside, 3r take outside 1.3, and r cube is a cube cos 2 theta into d theta. Now this is odd number. By Wallis formula, what do we get here? This is 2 upon 3 okay, into cos theta, but cos theta integrated as let me write it by Wallis formula. It is the integration of this. It will be 2 upon 3 k already there. 2 upon 3 integration of this a cube is also there. This is twice k a cube into by Wallis formula. Cos cube theta is 2 upon 3 into cos theta, and that will be pi by 2 also. 1 into pi by 2 will also come, because cos theta will be sin theta. Sorry, that will be 1 only. Answer is only 2 by 3. This is cos theta into 0 to pi by 2, but integration will be sin theta cos theta minus sin theta. But when we substitute pi by 2, it will be positive value. Okay, so 1 cos theta is left over, but integration of cos theta is sin theta, positive. It is positive here. Okay, so answer will be 1. That will be 2 by 3 into KAQ into 2 by 3 means 4 by 6, or 4 by 9 here. That's all. Why this 3? Okay, this 3 I have already taken. So this 2 upon 3 more or less fine. This is 4 upon 9 here. 4 upon 9. This 2 by 3 was there. AQ cos Q by 3. This is 2 by 3 next. Okay, because by Wallis formula we know that this is 4 by 9 here. Cos theta integrated to sin theta, but sin theta limits 0 to pi by 2. If I substitute, it will be 1 only, sin pi by 2 is 1. It is 0. So it is only 2 by 3. That is answer 4 by 9 KAQ. This is answer only. This is 1 at 0 sin 0 0. Finally, answer is 2 by 3 into this Wallis formula, using Wallis formula. Using Wallis formula. This I have discussed in detail previously. So using Wallis formula, when limits are 0 to pi by 2, that's integral, and cos q theta, cos any single sin n theta, cos n theta. Okay, if n is an odd number, even number. In this case, it is an odd number. Only 2 by 3 will come. Okay, only. Now we have discussed this cos theta there. That is 1 only. Only 2 by 3 comes out to be the result of this whole cube. 0 to pi by 2 cos q theta d theta. That means 2 by 3 only. This 2 by 3 we have already written, but this also comes out, but this comes out to be 1. Sin pi by 2 is 1. This is only 1. So 4 by 9 K8 3. That is the answer here. Okay, this 2 by 0 to be a 4 upon 9. Okay, so this is the answer. Finally, answer is 4 by 3, 4 by 9 K8. All right. Now let me take third question. What is question number 3 says? Let me check it. Now question number 3, what does it say? Question 3 says, find the mass of the region bounded by the plane x equal to 0, y equal to 0, z equal to 0, x plus y plus z equal to a. If the density at any point is k, x, y, z, this is 3-dimensional figure. This is third question. It is given to us. Let me take 2-dimensional figure first. This is x and y dash, o x dash. This is 2-dimensional figure. Let me take. Here it is x plus y, if z equal to 0 in this case. If z equal to 0, then x plus y equal to a. This is that line. Here it is a0, this is 0 a. This is, it means x plus y equal to a. In this case z is 0. So in this 2-dimensional figure, x and y, this is x-axis, this is y-axis. So in xy plane, z coordinate is 0. Z equal to 0. This implies that x plus y plus z equal to a. These are 3 figures. I mean, tetrahedron type of figure is there. Okay. This type of figure. For this y, this is z, and this is x. X-axis, this is origin. Okay, so in this 3-dimensional figure, if I take this 3-dimensional figure in proper manner, then it will be proper figure to be there. Okay, let me take this A, B, and this is C point. What are the points here? Because x plus y plus z equal to A. This is A0, 0. Sorry, this is y axis. It will be 0, A 0. Here it is A 0 0. This is 0 0 A. Now in this axis, y axis, this is x equal to 0. We are given here planes x equal to 0. X equal to 0 is y z plane. Here it is x z plane. Here it is y equal to 0. Now in this plane, let me write here. It is x equal to 0. Here it is z equal to 0. This is x y plane, like this. X y plane here. So this is what we call limits are suppose or strip we are drawn parallel to the x to y. What the y coordinates here? Y equal to 0 here on the axis of x, y equal to 0 to y equal to a minus x. Y equal to a minus x on this. So 0 to y coordinate is a minus x. And on the x-axis it is 0 to a only. X equal to 0 to x equal to a. 0 to a. X coordinates are. Okay, so this is x coordinate. What is z coordinate then? Z is equal to 0 to, here is z0. Okay, so z equal to 0 to z equal to a minus x minus y. This is from this line x plus y plus z equal to a. Z is therefore equal to a minus x minus y. A minus x minus y. Z equal to upper limit. Z equal to 0 to this. So on this plane figure, let me take a three-dimensional figure. If I draw strips, parallel strips in the this xy plane, this is in case of z x plane, and this is in case of right here. This is in the case of y z or z y plane. So in this plane, if I draw lines parallel to this z axis, then parallel to this axis here. In this way, we have to find out the limits. These are the limits here. The limits are different limits. Now let me write here. What is given to us? Given here x equal to 0 plane, y equal to 0 plane, z equal to 0, and x plus y plus z equal to a. Find the mass of the region bounded by the planes x equal to 0, y equal to 0, z equal to 0. This is that plane, complete plane, but this is in two-dimensional figure. I'm just understanding, taking this point. This in xy plane, z is 0. If z is 0, then x plus y equal to a only in that equation. If I put z here 0, so x plus y equal to a. Density at any point is kx by z. Okay. What is the volume therefore? Volume, these limits are given to us. Therefore, let me find out the solution. Solution. Here density rho is given as k x by z. No problem. Kx by g or z. Okay. Multiplication of these three variables. Now, what is the volume here? Total volume will be multiplication, triple multiplication for total mass. I have to find out. Total mass, therefore, total mass of the circle plate, or what is the mass of the region bounded by? Total mass of the region. Mass of the region bounded by these planes is equal to, or m is equal to triple integral. Let me first write triple integral or volume integral. That here will be rho into d.x.d.y dz. This is the final. But let me write now limits. First x limits. X limits is 0 to a. Y limits is y equal to 0 to a minus x. Z limit is 0 to a minus x minus y. Here value of rho is k into x by z into dx dy dz. Just let me integrate this first with respect to z. Then we will substitute the limits here. So that is our process is here. Let me find the integration of this one. Therefore, mass equal to 0 to A. Here K is the constant that we take outside. K are taken outside. Second is 0 to A minus x. First integration, let me write here x, y, okay, and z. X, y are taken up to this. And the third, this is for the z variables, z equal to f0 to a minus x minus y. A minus x minus y into this z into this is a dz here, then d.x.d.y outside. First we have to integrate this with respect to z. So integration will be shown like here. Integration of this will be this j times k is a constant here, 0 to a and 0 to a minus x. Okay, this is y varied for y limits, x limits, and limits for z. Let me integrate this. This is z square upon 2 integration from the limits here 0 to a minus x minus y into now d.x.d.y, dz are first are integrated this with respect to z. Now let me substitute the limit here. Let me take 1 upon common, k upon 2 outside, 0 to a, now 0 to a minus x limits. Now in place of z, if I substitute, sorry, this x by y also there, x into y was also there, it is x into y into, in place of z, if I substitute a minus x, it will be a minus x minus y whole square into d.x.d.y. The whole square of this, let me open, then multiply by that, and then integration. Finally, let me write below also. This is k upon 2, 0 to a, before multiplying by x by this integration 0 to a minus x. Now let me open this whole square. It will be, let me take a minus x whole square minus sign a minus x are taken one element and then or one variable, then minus y, it will be twice a minus x into y plus sign y square. This is the whole square of this a minus x minus y whole square, that means a minus x whole square minus 2 times a minus b a minus x into y plus y square. Okay. This is into d.x.d.y. First let me integrate this with respect to y, and then we will integrate with respect to x. This is dx finally. Now let me solve it further. Therefore, the mass of this figure, okay, tetrahedral type of figure, will be, therefore the mass m is equal to k upon 2 of this x by r to multiply inside. Let me multiply this, and then first limit is 0 to a, still we have not integrated, 0 to a minus x. First variable x into y into a minus x whole square, the first one, minus 2 times this x into y, it will be x into y square, for the limits are not substituted. Okay, still limits are, okay, are compute the limits. A minus x is still have to integrate with respect to y. Before that, let me multiply by x by inside, it will be x into y a minus x whole square minus twice a minus x. I'm sorry, this is a minus x, y into xy, that is xy square plus sign, this is y square into xy, that means x into y cube, x into y cube. Now this is to be integrated with respect to y, and then dx finally. Okay, that will be then finally 0 to, this is 0 to a minus x limits. Now let me integrate this further. Further integration of this now. Now we have to integrate with respect to y. With respect to y, this means y square. It will be k upon 2, 0 to a. Let me integrate this. It is x into y square upon 2 into a minus x whole square as it is. Minus sign this y square is integrated. This is 2 upon 3 into y cube into x into a minus x. This y cube upon 3 into y x, a minus x as it is, plus sign x as it is. This is y4 upon 4. Okay, now limits 0 to a minus x into dx. Limits 0 to a minus x now. In place of y variable, we have to put the limit 0 to a minus x. Now, a minus x is to be substituted in place of y. It will be k upon 2, 0 to a. Let me take it here. Now, this is x as it is. A minus x whole square. A minus x whole square will be x into a minus x whole 4 upon 2. First one, because y in place of y square, we have to substitute a minus x whole square, a minus x whole square, a minus x whole square, a minus x whole 4. It is there minus sign twice, x is there here. This is x into, this is a cube, okay, y cube, a minus x whole cube and a minus x whole 4 again. 2x upon 3 into a minus x whole 4. So this is y cube, this is a minus x. In place of y, we have to substitute a minus x. This one limit. It will be a minus x whole cube and a minus x whole 4. 2 upon 3x, right? And plus sign this one. This is also a minus x whole 4 because y 4 is there. It will be x into a minus x whole 4 upon 4. Now this is to be integrated with respect to x. Now dx is there. Now let me first solve it inside because they are similar or like terms. They are like terms here because x into a minus x whole 4. So twice minus sign. This is one time here. And this is 4, here 12. Okay. So LCM I have to take 12. So